In a previous video, a password identification system was demonstrated using AT89S52 microcontroller, programmed in assembly language. In this video, the Atmel microcontroller is again programmed in assembly to implement a guessing number game. A circuit diagram of the implemented system is shown here, which operates in the following way. The assembly code within the microcontroller starts by counting between 1 and 6 continuously. The user will then input a number between 1 and 6 and then press the enter button. The count will stop immediately and the input number is then compared with the captured number. If they are equal, then this yellow LED will start blinking, indicating that they are equal, and the buzzer will also tone. If the input number is less than the captured number, then this blue LED will turn on. And if the input number is greater than the captured number, the red LED will turn on. Now each time we press the enter button, the captured number will also be displayed at the output of port 3 through these LEDs. And now for a demonstration, the chosen input number here is binary 11, which is 3. Let's have a look at the assembly code used in the project. This part of the code represents the main routine, which does a countdown continuously from 6 to 1 until the enter button is pressed, where the count value is then captured. The program begins by setting port 2 for input and port 3 for output. Next, register R4 is used as a countdown register that will count from 6 to 1. In this instruction, we are initializing its value. Then we check the status of the switch. If the switch is not pressed, then this instruction will be ignored and the next instruction is executed, where the counter value is decremented by 1, and if it's non-zero, then it will jump to label loop 1. And thus we have a loop that will continue until the value of the counter is 0. Then this instruction will be executed, where a jump will happen to the start label and the process is repeated. So we have continuous countdown from 6 to 1 until the user presses the enter button, where the count value is then captured. While the counter is running, if we press the switch, then this instruction will be executed, where the program will jump to compare. And here at this location, the program will set port 0 for input, and then we get the input number from the user and store it within the accumulator. And then we store the captured number from the counter into register B. Next, we compare the contents of registers A and B. If they are not equal, then this instruction will be ignored. And here we are turning off the red and blue LEDs. And then we send the captured value to port B. And then we initialize a counter R3 that will loop 9 times, where first we turn on the yellow LED and then the buzzer. And then we apply a delay. And then we turn off the yellow LED and the buzzer, and then we apply a delay, and we loop 9 times to give a blinking effect of the yellow LED. After that, the program will jump to start, which is the beginning of the routine. At location not equal, the program will check the status of the carry flag. If it is set, then it will jump to this label greater, and the carry flag is set when the input number is greater than the captured number. If, on the other hand, the input number is less than the captured number, then the carry flag will be reset and this instruction will be ignored. And the program will then output the captured number to port 3, and then the blue LED will be on and the buzzer, and then we have a delay, and then we turn off the blue LED and the buzzer, and then we jump back to the beginning of the program. When the input number is greater than the captured number, then the program executes this instruction and the code will jump to label greater, where the captured value is sent to port P3, and then the red LED and the buzzer will be on. We apply delay and then turn off the red LED and the buzzer, and the program will jump back to the beginning of the code. In the near future, I'm planning to prepare a set of tutorials to teach assembly programming using the AT89S52 microcontroller. Thank you for watching.